All right, good morning. Happy Tuesday. Today we're going to continue with synthesis problems for aromatic substitution reactions. And tomorrow we'll start working on carbonyls. And the nice thing about that, I guess, for tomorrow is that a lot of the carbonyl chemistry is familiar because we saw some of them in the alcohol chapter. We'll add a couple of extra ones on top of that. Because we're going to do chapter 20, A and B for tomorrow, there actually won't be a new video for Thursday, so we can just work on problems before the quiz. Week 3 homework is up, and lab 5 homework, or lab 5, and then lab 6 is also available if you haven't already seen that, and that's a carbonyl lab. And then just a reminder that the quiz is available. Questions on any announcement type things? All right, so the first thing that we're going to do today is some reactions. So I'm going to switch the camera here. And we'll look at our reactions. So we're on the functional group page. And we just have a couple of reactions to add today. So this is page 8, and I think I just have one spot left at the bottom here. And this is a reaction for if you have a bromine present. So the bromine is needed. And you also need an electron withdrawing group, either ortho or para to that bromine. And then you add to that sodium hydroxide. And that's heated at 70 degrees. And you follow that with some acid, and that will make phenol out of that Br. If those electron withdrawing groups are not present, you won't be able to do that reaction at 70 degrees. You would have to heat that one up, I think, to 100 or 350 degrees, I think Celsius was what it was, so pretty hot. So for this one, you need that electron withdrawing group on the ortho or para position. They don't have to be on both. All right, and then on page 9, keep that up here. If you have chlorobenzene, we add NaNH2. So we used that NaNH2 before in a lot of reactions with alkynes, either to form the alkyne or to do a reaction with it. So we know it's pretty nucleophilic. And if you add that sodium amide to chlorobenzene, that will actually make aniline. So if you had a chlorine on your benzene ring and you wanted to swap that out with an amine, you can do it doing that reaction. So this would be instead of going through the nitro group. But you could also go through the nitro group to get that amine. It'll just depend on whatever else you had on the ring. And then we have a reaction of toluene. This is a reaction we've seen already, just not in excess. So if you add N-bromosuccinimide in excess, we make 3 Br groups on that benzoic carbon. You might see that sometimes written as CBr3. So this would be a way if you had the CH3 here, which is an ortho para director, to swap it out to a meta director. So adding all of these bromines on here makes this group electron withdrawing, which would direct the next group meta. All right, questions on any of these reactions that we have? Those are the only 3 that we need to add today. All right, so in this question here, what is the major product if you have para-nitrobromobenzene and we react it with sodium hydroxide followed by acid? All right, so most of you went with B, which is the correct answer here. We're going to swap out that bromine for the OH, and we can do that because there is an electron withdrawing group present at the para position. So B is the right answer there. Any questions on that one? All right, we have no reaction here because there's no electron withdrawing group on the ortho or para positions there. So that one will be a no reaction. What if we have the chlorobenzene and we treat it with sodium hydroxide at 350 degrees? All right, good. So the chlorine or the sodium hydroxide is going to take the place of the chlorine. It's not going to add in addition to, and this will direct it in the para position, or actually not para. It will just swap it out. So we'll get C for the answer here. So we can do this reaction because there is extreme heat. All right, what if we have the chlorine with sodium amide and liquid ammonia? What do we get there? All right, so for this one, the chlorine is going to get substituted with the NH2. And so we're just going to get B for our answer there. So this is another way to make aniline is by going through the benzyne intermediate, which had the triple bond in the benzene ring. Okay, number 19 of your problem set is to predict this reaction. We have a bromine, chlorine, and a nitro group present here. And we're going to substitute, try to substitute sodium methoxide with heat. So this reaction mimics NaOH. And so the question here is, are we going to substitute the chlorine or the bromine? And to answer that question, you want to look at, if you remember on our reaction tables that we just did, we need to have an electron withdrawing group that is ortho or para. The nitro group is our electron withdrawing group, and it's not ortho to anything, but it is para to the chlorine. So we're going to substitute that chlorine with NaOMe. So if this is our nitro group here, the chlorine will become the OMe or OCH3, and then our bromine is still there. All right, any questions on that one? So the NaO-methoxy is going to react the same way that an NaOH it would as well. Okay, so this one is a multi-step reaction. So first we're going to look at this para-bromotoluene. We're going to add HNO3, H2SO4. So this should hopefully indicate to you that we're going to add an NO2 group, but now we have to decide where it's going to go. And the one that is directing here is going to be the stronger activator, which is the methyl group. And the methyl group is, we said it was an activator. It's going to direct ortho and para. And right now the para position is taken. So for step number 1, we're going to add an NO2 group to the ortho position. All right, any questions there? Okay, so steps 2 and 3 go together. So that zinc HCl and NaOH are this part of the same reaction step. So it's not 2 separate ones. So what do you think the product will be if we add zinc to that? All right, so zinc HCl is going to be a reducing reagent, and it's going to reduce the nitro group only, and it will reduce it to the NH2 and leave everything else alone. So our answer here is going to be D. Any questions there? All right, how about this one? Why don't you guys try this one and see what you get for that one? We'll give you 2 minutes. Okay, so in the first step, we're going to add this acyl group here, and both of these methyl groups are ortho directors, and the molecule happens to be symmetric. So we're gonna, wherever we add it doesn't really matter at this point. So it should go to one of the ortho positions. So after we do step 1, that will give us A. However, we have another step on there, which is the zinc amalgam, and that is going to reduce our carbonyl to a alkane. And so our answer here is going to be B. Any questions on that one? So this is a way to add a straight alkyl chain without having to worry about the rearrangement that could happen. All right, so in number 34, the synthesis that is written here is not going to work. So we have to find which step is problematic here. So which step do you think is going to be the problem? Okay, so the first step with benzene, there shouldn't be any problems there because there's nothing else on the ring. So that will give us nitrobenzene. But the people that answered with B being the problem, why can't we do the ethyl chloride with aluminum trichloride? Is it directing to the wrong position? Or what is going on with that one? Why won't step B work? So the nitro group is electron withdrawing. And we cannot do Friedel-Crafts reactions, which is what this one is, when there's an electron withdrawing group up there. In order to synthesize that nitroethylbenzene or that meta nitroethylbenzene, we can start with benzene. If I add just ethyl chloride with aluminum trichloride, that will put the ethyl group on there, but this is an orthopara director. And that meta group, I'm sorry, the nitro group is meta to that. So instead of doing that, I'm going to use the chlorine with the carbonyl with AlCl3. And now I have an electron withdrawing group. So when I add my nitro group, that one is going to be directed meta. And then I can reduce my carbonyl using zinc amalgam and HCl. Okay, any questions on that particular problem? Okay, let's take a look at the next one. If I can get back to that one. I don't know what just happened. Okay, so what is wrong with this synthesis? All right, so some of you chose A, some chose B, and some chose C. So we'll take a look at these more closely here. For order of addition, you might be worried that a Friedel-Crafts cannot happen with the halogen, but we can do Friedel-Crafts with the halogen. So that one, the steps order is okay. So we can do Friedel-Crafts with halogens. Okay, so that step is okay, or the synthesis is okay in terms of the order of the reaction steps. For B, the location or directing effects, if we add bromine to the ring first, which would happen after, that would be the steps for the first one, even though bromine is deactivating, that one is an ortho-para director, and the second group that's getting added is para. So this one is also okay. For a rearrangement, that one is going to be the problem here, because if you form your carbocation after that chlorine leaves, it's a primary carbocation, which is not stable. So this one will rearrange to the secondary carbocation. So what you will actually make is an isopropyl group there. Instead. So this will be the actual product that is formed, not the one that is there. So there was a question about why we don't add carbons first there. You can add the carbons first if you want. So if you wanted to, you could switch the order around, but we can still do Friedel-Crafts reactions if there is a halogen there. In this case, it doesn't really matter. So to do the forward reaction for this one, we can do the benzene, or I'm sorry, the bromine first or the alkyl chain first. Right, so my computer's just a bit slow here today. So I'll do this synthesis for you. And we'll start with the bromine. This will make bromobenzene. And that one is an ortho-para director. So we can keep that in our back of our head. The ortho is going to be the slower one to react and more sterically hindered. So the preference will be for the para. And so when we add our group to avoid the rearrangement, we're going to add the chlorine there or with the acyl group. So 3 carbons. And then we can do the zinc amalgam to reduce. And we can also do this with the benzene first, not benzene, the acyl group first. With the 3 carbons. One thing that we do have to do before we put the bromine on, though, is to reduce this carbonyl because this is a meta director. And we don't want it to go meta, we want it to go para. So I'll do zinc, amalgam, and then the Br2. So it is a good idea to put the carbons on first, but sometimes it will work either way. Because Br is a very weak deactivating group, that one's not going to stop the Friedel-Crafts reaction. Questions on that one? All right, let's look at the next one. Okay, what is wrong with this synthesis? All right, so two of you that voted for B, which is the location. If we have benzene plus bromine, we get bromobenzene. This one is an ortho pair director, so we would not get one at the meta position. So B is the correct answer here. In order to fix this synthesis, all we have to do is change the order of operation. So if you wanted to make the target molecule there, just make this one number 1. That will add the acyl group. That's a meta director, and then use this as number 2. So that is how you can make that compound instead. Any questions there? All right, how about this one? What is wrong here? Okay, so some of you voted for C, the rearrangement. And to figure out if you have a rearrangement or not, you can take the group that is being added and just, draw the leaving group leaving. The carbocation that we get here is tertiary, and that is a stable carbocation, so there's no rearrangement here. But when we do make tert-butyl-benzene, tert-butyl groups we know are very bulky, but this one is an ortho-para director. But because of the bulk here, it's very unlikely that we're going to get an ortho addition. So this one would actually be para. So B would be the correct one here. If you wanted to synthesize that compound up there, we would have to employ the blocking group. And to do that, we use the H2SO4, the fuming. And that will add that SO3H group that's para. Again, it's going para because of sterics. And then we would add the Br group. And because the para position is blocked, it's forced to go to the ortho position. And then to remove the group, we just use dilute H2SO4. All right, any questions on that one? All right, so here is one where we have to do the synthesis of benzene. We start with benzene and we can use any reagents here. So observations that you want to make. We have bromine. We're adding a propyl. And we have an NH2. So a couple of things that you want to note about the propyl group. That one is a straight chain. And so this one could undergo rearrangement if we tried to add it as is. We have two ways of putting that NH2 group on there. We can either go through the nitro group or the Cl. And as the groups are located, the nitrogen, the amine, is an ortho-para director. The bromine is an ortho-para director. And this carbon group here is an ortho-para director. So you want to look at the relationship of the groups to each other. So for example, the Br is meta to the amine. The Br is ortho to the alkyl group here. And the alkyl group is ortho to the Br and it's para to the amine. So you want to think about what order that we add things in here. So I'll give you a couple of minutes to try to come up with a couple of steps or ideas for steps, and then we can collect ourselves and see what we get together. Okay, so hopefully you either added the bromine first or the carbon first. We definitely don't want to add the nitro group first because that is a meta director, and then if we try to add the carbons after that, it won't work. So in this case, you can either start with the bromine first or the carbon first. So just for practice sake here, we can add our carbon first. And I mentioned that there is a possibility of rearrangement with that straight propyl group. So we're going to have to add it with the carbonyl. So I'm adding 3 carbons, AlCl3. Okay, so at this point you can decide if you want to reduce it to the alkane or if you want to just continue with the synthesis. And you want to look at what type of group is on there. If you have a carbon double bonded to oxygen, this is a meta director. So the next group that we add is going to be meta to this group that we have on there, which we don't want. So we want to reduce our carbonyl right away because the bromine is ortho to that group and the nitro group is para, or the amine group is para. So we have our alkyl chain, and this is now an ortho-para director. And I'm going to add the para group first because it is opposite, and that one sterically is favored. Okay, so there is our NO2 group. And then we want to add the bromine. And you can also contemplate reducing that nitrogen or that nitro group to the amine. But if I do that, that one's going to be a stronger activator, and then it will try to push the next group, ortho or para, to that. So we'll add the bromine before reducing the NO2 group. Because the propyl group is the activator here. And that's the ortho para director. So that one is going to win the battle of driving the bus. So that next bromine that gets put on is going to be ortho to the other group. So after we do this, then we can reduce the nitro group. All right, so if we reduce the nitro group too soon, then it's going to drive the bus. It'll take over for the propyl group, and we don't want that to happen. If you wanted to put your nitro or your amine group in via a chlorine, you could do that as well. So we'll just give you a couple options. So you could just use Cl2 and use that new reaction that you learned today. And then do the NaNH2. Well, you would add the bromine first. And then NaNH2. So that's another option. And if you wanted to put the bromine on first instead of the carbon, you could also do that, which would be fine because the bromine is an ortho para director. So let's say you had put the bromine on first. The next group would go on to here. Then you would do the reduction, and once you reduced it, the propyl group will be the one driving the bus again between that and the bromine, because halogens always lose there. So at this point, if you added the nitro group, that one would go para. All right, any questions there? All right, what are we going to do first here? Do you want to add the tert butyl group first or the ethyl group first? Or does it matter? Okay, so if we add let's add the tert butyl first. We start with benzene. So to figure out what you're adding here, we just take that whole group and add a chlorine to that. And then once we add our tert butyl group, hopefully you quickly realize this is an ortho para director, and this group is meta to the tert butyl group. So we're going to have to add the ethyl group first, and we're going to have to add it with the carbonyl. And we can't use a carbonyl on the tert butyl because that would be too many bonds to carbon. So we add that with AlCl3. And we want it to direct meta, so we don't want to reduce this yet. Then we add our tert butyl group. And then we can reduce. Okay, any questions on that one? What about this one here? We have phenol with an ortho methyl group. And the only way we have right now to add the OH group is through a BR. That's the reaction that we learned today. And then methyl groups we can add without too many issues there. So what would we do here? Or anybody have ideas? So it probably would be a good idea to add our benzene carbons first. And this is just one CH3. We don't have to worry about it rearranging. And then if I'm going to add my OH via a BR, I can put a blocking group on there because I want it to go ortho. Actually, I might run into a problem here. The blocking group is going to go para to the methyl group, but it is meta to the bromine. And in order to do the OH here, I need my electron withdrawing group para. So I actually need to add my BR first. So this one is not going to work. That's okay. We wanted to start from scratch anyway, right? questions there? All right, we'll get back to the book problems here. This was just a made-up one. All right, so this one has 4 different things on it. We have an NH2 and a tert butyl group. And then 2 chlorines. So something that I observe about this is I want to add my carbons first. And you can add an NH2 via a chlorine, but we already have other chlorines on here, and that can get pretty confusing here. So I'm going to go forward with a synthesis and kind of talk my way through this one. So if I'm adding my carbons first, I will add the tert butyl group first. That tert butyl group is an ortho para director. So the next group I add is going to be para, and I'm going to add the nitro group next, because that one is already para. Tert butyl is large, and so I don't have to worry about that going ortho. All right, and then the groups that I want to add are the chlorines, which are meta to the tert butyl group, which is the one driving the bus right now. And I don't want the groups to be, because the tert butyl drives it ortho para, all the positions are really taken. So I want to pass off the driver to somebody else. And I can allow the nitro group to drive if I reduce that. So I'm going to reduce this to the amine, because the stronger activator on the benzene ring is the one that is directing the next group that gets added. And so the NH2 is the driver of the bus now, because that's a stronger activator. And that is an ortho para director. The ortho groups are available. And so we can add groups there. And to add 2 ortho groups, we just need an excess of chlorine. And you can add that twice. Right, questions on how we got to that? All right, on this one, it's the same thing. Benzene, we're going to do a synthesis. I have 2 carboxyl groups here, which are the same as this, so carboxylic acids, and a nitro group. One of the nitro groups is ortho to one of the benzene or benzoic acid, the carboxylic acid groups there. So that might have been something before it was carboxylic acid. So we could have had this prior to that and then did an oxidation with the Jones reagent or KMNO4 in order to get those 2 benzoic acids. So what you could do is add 1 carbon to make toluene. And then add the other carbon at the para position, because that methyl group is an ortho para director. Then add your nitro group, which is forced to the ortho position. And then to get to the last step here, we can use the Jones reagent. questions on that one? Okay, if we look at this one, we have an NO2, another tert butyl, BrCl. The tert butyl group is the one that is going to be driving the directing effects because that's the only activator on here. And also that's a carbon, so we want to add that one first. And then whatever groups I add after that, the tert butyl groups is still going to be the one directing the next group on there. And the Cl and the Br are ortho to that tert butyl group, and the nitro is para. So I'm going to block the para position first, or add that nitro group first, or next, I should say. And then we can add the chlorine and the bromine, which will go on either ortho side. All right, any questions on that one? The next one is kind of similar, and it might seem like having all those extra groups makes it that much more complicated, but it doesn't have to be. So we're adding an acyl group, isopropyl group, nitro, and a chlorine. And the isopropyl group is the only group here that is an activator. So that one is going to be the one that's directing. And if you notice here, we have the same kind of pattern where there's a group that is para and then two ortho groups. So we can add that isopropyl group first. And I don't have to worry about a rearrangement there. We don't want to add that acyl group first because that one is a meta director. And that would be okay for the nitro and the chlorine, but we'd have a hard time getting that isopropyl group on there afterwards. So now I can add the acyl group. And once we have that acyl group on there, then I can add the nitro group. And at this point, the order of nitro and chlorine don't really matter. Any questions on that one? All right, that was the last one I had from the problem set book. So if you have questions, I'm happy to answer them. Otherwise, if you come up with other things that you're not sure about, you can ask at a later time. The extra video or the problem with the extra videos is posted if you want to get some more practice on the synthesis problems. And if you have nothing, I will see you tomorrow.